been asked to do a little presentation on our evolution of scanning on site. This is it. So we originally decided to go with scanners for many reasons. One of the most important ones was removing the surveyors from high walls. And a lot of our work was doing batter checks on foot, up against the high wall, high exposure, pretty dangerous, not a very good spot for GPS location either, so you don't always get the best result either. Removing the surveyor from the high wall has always been the aim. We actually went down the path of the VX system for a while, but that wasn't just in terms of speed. It was kind of a slow process. So the scanner was really the way to go for us. It actually allows us to survey huge amounts of area quickly and outside of peak movements from trucks or dig units. Reduces our exposure from heavy vehicles, of course, and allows us to like showing that picture at the bottom, give a much more detailed picture of how the walls are performing in terms of excavation and geotechnical risks. Previously, before we would just survey the tow line and project a crest, so we weren't really getting quality data. Also, with the surveyor parked in a vehicle for most of the time, you can avoid a lot of those other hazards such as dust and heat, slips and trips, all that sort of thing. Lifting. Our instrument of choice was the Regal VZ1000 and now the 2000, which we get a range of up to 2.5 k's, a minimum of 1. 500, up to 500,000 measurements per second, and it's around the 10 kilos in weight. Typically we're getting 30 to 40 scans within an hour of driving in the pit, 15 seconds per 360 scan, so it's very efficient. Originally we were starting with just setups on tripods with GPS on the top. Slowly evolved over time to the roof rack scenario with the step, and it became a bit of an issue in terms of lifting and a safety problem for people to maintain the grip of handles and so on. It became quite difficult, especially for the shorter people. And then we developed a hydraulic lift, which is positioned on the back in the position of one of our spare tyres. So it's quite a large capability of that lift. I can't remember the exact figure. Paul, are you aware of the lifting capability of that lift?
No, but it's over-engineered by a factor of 3 or 4.
Yeah. So it's very capable of lifting the weight of the 10 kilo scanner.
Not confident in keeping the scanner on the car full time?
We will use it in a pit scenario for maybe the 10 to 15 scans, and then remove it, drive to another pit, and then re-erect it. Yeah. So we wouldn't drive large distances between pits. I mean, you probably could. I think a few of us have, but we don't recommend it. Yeah. There is those small arms have some compression and.
I suppose it was an unknown that, depending on the condition of the roads and how many k's you drive, if we kept doing it for several years and then you got to send it back to Austria, you're down a scanner, so you might do, we don't know. Really
we actually found the link between the scanner and the GPS was the failure point. That was a bit more of an issue than the actual scanner itself. So sorry, the power systems all integrated into the vehicle, so powers the scanner and the lift. So we have to have an extra battery in our vehicle to actually keep the power. The power for the lift is quite substantial. Lift controls are on the dash, so power for the lift and for the scanner, and an up and down switch. Takes about about 10 seconds for the lift to go up or down. That's our mounting plate for the scanner with the vibration dampeners underneath. It's got a hardwired power system, so it just goes straight into the scanner. That's our new GPS mount, so that creates those 3 points of contact for the GPS, so there's much less vibration for the GPS when it's on top. As you imagine, it's quite a long way up off the centre of gravity for the whole vehicle when it's up at full extension, so any sort of movement as you're driving around is quite large. This is just an example of what it was. This is just a quick preview of the scanner actually on the vehicle. That was just showing the vehicle driving up and down with the lift. We found that we usually need at least a minimum of 4 scan positions per area that you're scanning. So most of us get about 5 to 6, but a minimum of 4. We also found that a lot of the features that we're picking up are actually quite linear. So there was a tendency for people to drive along a long high wall and get many scan positions in a linear line, and then it would actually, when everything was stitched together, the whole program or whole job would sort of rotate around that linear line and create error. So we actually make sure that everyone does a staggered approach for their scan positions, and that helps a lot. Each of the GPS positions are recorded at the beginning of the scan, and you just have to make sure that you're choosing subsequent positions that have enough overlap with the previous scans. Data check conformance is probably one of our main uses for the data. Allows geotechs to see how close we are to design. A lot of people looking at ramp conformance at the moment with gradients and widths and all that sort of stuff. So there's a large amount of works in that area at the moment on a lot of our sites. Tailing storage facilities, capacities and deformation. Geological reflectors, so a lot of the features in the geological structures on the face of dig faces that we can't really easily get any other way. We can actually show that up in the reflectors data. And just general pit updates for the pit. So a lot of mine roads, dump positions, even just general cleanup for drilling. That's a screenshot from a batter check, just showing our conformance to design, and a cross section below, so just showing whether we're over digging at the top or whatever. Really helpful for the drill and blast teams as well to design subsequent shots if there's any sort of problems that they're finding in that particular area. That's an example of some of the reflectance data that the geologists are given, and they start mapping some of that data as well. That's some infrastructure data. We haven't done a lot of work in that space yet, but there's definitely a lot of scope there for that sort of work. I'm just going to run through a quick demo of some data that we've got here. So this is the process. There's a USB stick on the side of the scanner that we can. It actually just writes straight to the USB stick and then walks straight into the office and start the process straight away. We effectively get a triangulation of the data within 5 to 10 minutes, we'd have a triangulation ready for Vulcan or something similar.
Warwick is screen already.
Sorry. So this is just bringing in your scan data and your positional data from your GPS positions. We need to actually apply those positional information to each of those scan positions now in a direct georeferencing process, setting your height offset for your scanner to your GPS base center. And that goes away and does that for you. Then it's simply a matter of loading up each of your scans into this window. And you get something like that. So obviously everything's not orientated correctly. So we use a process called A3 registration, which rotates all of those scans until surfaces are found of commonality, and then it actually rotates all the scans and gives you an output sheet of what the quality is. So if I zoom out, you can actually see it rotate them all as it goes.
They'll rotate around those GPS positions.
Correct, yeah. That's a pretty poor result. I'm not sure why that's happened there. Sorry. Let me start online. Sorry. I did say 5 to 10 minutes. So you can actually zoom in and look around at the data as it's realigning, and see detail in the walls becoming closer and closer to one plane. So this gives you just an idea of how much it's rotating each scan and each scan position, and a bit of an idea of the GPS accuracy. Some of these appear to be a little bit out. I'm not sure what's happened there. They may have lost lock on some of them, but we can actually run these a few times, and it actually adjusts those results slightly to get the best answer. And with the smallest amount of residuals. I think this data that's shown here is due to those GPS. There's a couple of 1.5 metre accuracies. I don't know. That's quite unusual. There must have been a couple of points in there that were badly recorded at the time of scan. But anyway, if I go back to actually from this point on, we normally create one piece of poly data, which is a combination of all those scans together. So you'd select all your scans, activate range gate, which allows us to remove any data within a set range. So we've got it currently set to 4 metres. Those close scans of the vehicle. I can actually show them to you. It's actually just to remove all that sort of data around the vehicle. And so we use range gate for removing those close points, and then an off-tree filter which actually removes any unnecessary data that's not required down to an increment of 0.1. And then it combines all those, this is actually 16 scans, I believe, into one object. So press OK on there, and track that running down the bottom. And then that'll create a new poly data set. So there's your final product from the data. So from here, we generally select all our data and run a filter for any mining objects or vegetation. So this will go away and select all vertical faces that may be present in the data, so lighting plants and delineators and trucks and excavators, etc. And then it just removes that and actually leaves us with ground data only. You see it's selected haul truck there. And, there's a dig unit up here as well. So we delete that data for this example, and then from here we would create a triangulation, and you can, from here you can actually choose what size triangulation, your smallest triangles, maximum tilt angles between your triangles, your minimum triangle angles, and then it'll go away and produce a triangulation for you. From this point, we would generally just export a DXF into MicroStation, into MapTech Vulkan, and digitise a lot of points and strings from that point on. It's quite a laborious task, of course, because it's a lot of information, but we really need to work on something that allows us to get away from the manual digitising. It's kind of a very long-winded way of getting the data into that technical. A lot of the time, this information is too large for Vulcan to handle as well, so we've had to reduce our triangulation numbers. So the site that I actually worked on, we actually were using old traditional methods with GPS on the front bumper of the vehicle, and you know it was quite a slow process, of course. So we actually had one of our team members from the project survey teams come to site and train us all in the use of the scanner and helped us get the fit out completed with the lift. Once everything was set up and we were ready to go, we've pretty much completely converted to using the scanner. It's effectively good for 95% of the pickup work that we do now. And before it actually arrived, we thought there would be no way that would be the case. We just assumed that it would use a GPS for a lot longer than we had to, than we did. But the GPS is very slow and compared to the data, and a lot of the times you're completing surveys of areas that you think you know what you want to pick up. You do a few scans and then get back to the office and you'll find there's other areas that have changed, and will help you keep the model up to date more than you probably would on a regular site with just GPS. And that's our final asset list of all the scanners we have on sites across the Pilbara now. We have a few floating units for servicing that we swap out, and they're slowly being replaced by the 2000 series, which is a bit lighter and a bit faster. But yeah, that's about it. You got any questions? Sure.
How do you go with integration of UAV data with the laser scan data? Is that all going to Vulcan as well?
The UAV data?
Yeah.
We do, yeah. We don't actually tie it with our scan data. I mean, we use the scan data as a bit of a check, yeah. But yeah, the two aren't really integrated at the moment for us.